This is section 9.1 and geometric series quiz review. Find the third degree Taylor polynomial centered at x equals 1 for f of x. Use the polynomial to estimate f of 1.2. What is the error in the approximation? So let's find f of 1. That's e to the 1 minus 1. That's e to the 0, which is 1. And then the first derivative of this right here is negative e to the 1 minus x. And when we plug 1 in, we get e to the 0 again, so that ends up being minus 1. Second derivative is e to the 1 minus x, and that's a positive 1. And then the third derivative is negative e to the 1 minus x, and that is negative 1. The third degree polynomial is 1 minus x minus 1 plus x minus 1 squared over 2 factorial, and then minus x minus 1 to the third over 3 factorial. Now we're going to use this polynomial to estimate 1.2. So let's get this turned on here. 1 minus 0.2 plus 0.2 squared divided by 2, and then minus 0.2 to the third, and that divided by 6. So we get 0.818, and then 1, 2, 3, I guess there's 4, 5, 6, and then it rounds it at the end. Now we want to find out what f of 1.2 is. That's e to the 1 minus 1.2. There's, we'll call that the actual answer. 0.81873075531, and then we want to find the error in this approximation. So we're going to subtract the 2, and we really aren't really that concerned about whether it's negative or not, because we'll just make it positive. So there is the error, which is 0.12345640864. Find a geometric power series to represent the given function and identify its interval of convergence. When writing the power series, include the sigma notation for the series. So a sub 1 is 5, r is 4x. The series is 5 plus, let's write it like this, 5 times 4x plus 5 times 16x squared plus 5 times 64x to the third. Keep on going. So we found the series. Includes this sigma notation. So let's get the nth term. That's 5 times 4 to the, let's go, we can even go 4x to the n if we start with 0. So we're starting with 0. And so let's write the sigma notation. That tells us that we're starting with 0 to infinity of 5 times 4x to the n. Now we want the absolute value of 4x to be less than 1 in order to find the interval of convergence. So negative 1 less than 4x is less than 1. So negative 1/4 is less than x is less than 1/4. So the interval of convergence is negative 1/4 to 1/4. On this one, a sub 1 is 1, and then r is, well, x minus 5. So that's going to be 1 plus x minus 5 plus x minus 5 squared plus x minus 5 to the third. Keep on going. So that means it's just x minus 5 to the n, starting with 0. When we write the sigma notation, we get to say that we're starting with 0. So it's just x minus 5 to the n. Now the absolute value of x minus 5 needs to be less than 1. So negative 1 is less than x minus 5 is less than 1. And then add 5. 4 is less than x is less than 6. So the interval of convergence is 4 to 6. Here a sub 1 is 2. R is x to the 4th. So that means we have 2 plus 2x to the 4th plus 2x to the 8th plus 2x to the 12th. Now the nth term is 2x to the 4n. Let's write the sigma notation. N equals 0 to infinity of 2x to the 4n. Now we say that x to the fourth has to be less than 1. Then when we take the fourth root of this, x has to be less than 1. Actually, the absolute value of x has to be less than 1. So negative 1 less than x less than 1. So the interval of convergence for this is negative 1 to 1. Determine A, whether the terms whether the terms converge to a value, and B, whether the series is convergent. So A will do the limit as n approaches infinity of 3n over 7n plus 1, and that is 3/7. So converges to 3/7. B, is the series convergent? Well, 3/7 does not equal 0. So diverges. Diverges by nth term test. Here A is limit as n approaches infinity of 5 over 2 to the n. Well, that's going to be 0. So this converges to 0. B, the r is 1/2 for this geometric series. The absolute value of 1/2 is less than 1, which means this converges by geometric series. Determine whether the given series converges or diverges. If the series converges, find the sum. Well, r is 2/3, and the absolute value of 2/3 is less than 1. So this converges by geometric series. And we're supposed to find the sum. Well, a sub 1 is equal to 2/3. So S, the sum, is 2/3 over 1 minus 2/3. That's 2/3 over 1/3. So that's 2/3 times 3. So this converges to 2. Over here, this is, over here, this is geometric as well, where a sub 1 is 1 and r is 4/5. Now the absolute value of 4/5 is less than 1, so this converges by geometric series. The sum is equal to 1 over 1 minus 4/5, which is 1 over 1/5, which is 5. Let's list out the terms here. When we plug 1 in, we get 2 over, well, 5 to the 0 is 1, so we get 2. Then when we plug 2 in, we get 4 over 5, 4/5. So then when we plug 3 in, we get 8 over 25. So a sub 1 is 2, and r is, we're multiplying by 2/5 on this. This is geometric. The absolute value of 2/5 is less than 1, so this converges by geometric series. The sum is equal to a sub 1 over 1 minus r, which is 2 over, 3/5? And so that's 2 times 5/3. So this converges to 10/3. On letter D, this is the same as n equals 1 to infinity of 1 over 4 to the n. So a sub 1 is 1/4, and the r is 1/4. A sub 1 is 1/4. R is also 1/4. This, we say that the absolute value of 1/4 is less than 1. So this converges by geometric series. The sum is equal to 1/4 over 1 minus 1/4. And that's a 1/4 over 3/4. We're going to take 1/4 times 4/3. So this converges, the sum is 1/3. Nth term test for divergence. If the limit as n approaches infinity of a sub n does not equal 0, then the series diverges. So we can say that, what can we say with this? If, if the series diverges, then how do I want to say this? Let's do it this way. We're going to say if the limit as n approaches infinity is of a sub n is equal to 0, then we don't know anything. So the series could diverge, such as n equals 1 to infinity of 1 over n. This one diverges. And the series n equals 1 to infinity of 1 over n squared, this one converges. So both of these, the terms are going to 0, but one diverges, one converges. So that's why this is a divergence test. Because the only way we can say that something diverges because of the nth term test is if it's not 0. So if a sub n is not 0, then we know that the series for sure diverges. So then we can say, well, if the series converges, what do we know about the terms? Well, we don't know anything. If it converges, then the terms certainly went to 0. If the series diverges, then the sequence could have gone to 0, but it also could not have gone to 0. So we don't know anything if the series diverges about the terms.